Good morning, friends. Today I'll show you how to design a loading siding from mainline. How we are designing the siding, that I'll show you. Okay, and step by step I'll draw. Step by step I'll tell why I have done it, so you can understand what to do. Thank you, friends. In the picture, there is the existing up and down lines near to a station, and from there we'll take the siding line. So, better survey the station and find if any shunting neck or spare lines is there. Just the end of the yard, near to the yard end, that will be the last line. After that there will be no line, and use that line as your takeoff. That means your siding line will start from there. Here I have shown there is a shunting neck. So shunting neck crossover will use as its takeoff. Generally there will be no crossover in the up and down line for the shunting neck. So we have to, if there is no crossover, favorable crossover, then you have to design a crossover also, so that on any line the train can come from the up line to the siding and can go from the siding to the down line. And somewhere they are taking Y connection, because the train can move both sides, up direction or down direction. Y connection I will show you later. Initially better to see it, how to design. During survey, another thing you have to see, that for this new OHE wiring, how many obstruction of existing OHE or infringement of existing OHE, and that to be dismantled and will be modified, that you have to assess. You have to assess that thing, survey the takeoff point, and your takeoff will be overlap type. Nowadays all are overlap type. So see, for taking overlap wiring, how many mast and OHE, anchor, everything you have to assess to dismantle it for the new siding wiring. This is the station survey, and you have to check it carefully. You have to maintain the standard span, the obligatory mast of the takeoff point, the overlap turnout of the siding, everything you have to plan. Later I will show you with an LOP. And the next thing is the power supply. Generally what we are doing, we are taking two interrupters, one from upline and one for downline. If it is more than up and down line, take the two end line. That means last line of up direction and last line of down direction, and from there you connect this, so that power interruption should not occur. If you take only from up line, then what will happen during power block on upline, the siding will not get any power. You have to confirm the reliability of power supply. So you are taking up and down, or the two up and down last line, if multiple lines are there, so that it will be not under shutdown immediately. Another thing also we are doing, we are providing an isolator from where the takeoff point has been taken, because your SSP may be under maintenance. The new SSP may be under, during that time you can give siding supply to this isolator. So this is the basic idea of the siding initial stage where it has started. So what and after that, two interrupter will provide a circuit breaker in the common portion. Output of the two interrupters will provide a circuit breaker, because nowadays, not to disturb the main line, we are providing circuit breaker. If any fault is there in the siding line, the circuit breaker will trip and not disturb the main line. But if you keep it in manual isolation, then it will harm. It will take time and main line will be affected for more time. So nowadays we are using circuit breaker to feed the siding line, and as standby supply means an isolator to the turnout point of the siding with sectioning arrangement. That means you have to insulate the main line from the siding line by section insulator, by insulated overlap, by PTFE neutral section. So many things you can do, but you have to insulate the siding line from the main line, main yard, not line, main yard, so that main yard to siding line is fully separate sections, will be separate section. So what we will do, first I am showing you the sectioning of the siding line, how we are doing it. So to insulate the main yard from the siding line, we have provided a section insulator, and for making continuity of power supply, for emergency there is an single pole isolator. This is the system. It can be closed in emergency. Okay. Next, we will prepare for power supply to the siding line. This is the power supply installation portion. First you erect the OHE, then arrange power supply, then take permission EIG for commissioning the siding line. Here we have shown the circuit breaker. Now we'll slowly draw the siding line. For designing the siding line, first you have to check the wind zone of that area. According to the wind pressure zone, you have to decide the span of the OHE mast. That means the distance from one mast to another. You have to also consider the curvature, because in curvature the span will be reduced. Then the height of the OHE over. Generally it is in open root it is 5.80 meter, but when the shade will come and where loading unloading will be done, that the height will be reduced. Because under it the loading unloading will be taken. So you have to consider the wind pressure zone, you have to consider the span, you have to consider the curvature, you have to design the size of the OHE mast, the soil bearing pressure you have to check. With the soil bearing pressure you have to design the foundations, what type of foundation you will do, and the tension length, what will be the tension length of the siding line wire you will terminate, and what will be its length, what anchor to be provided, type of anchor foundation, all are interconnected with it. Okay, but the major thing is the wind pressure, then selection of span, selection of mast, selection of foundation, loading siding, OHE height, other of the siding OHE height, everything you have to consider for designing the section. And if you provide the insulated overlap for sectioning or section insulator, if your siding is long, we have designed it at ESL siding in other division where the length of the track was too much. We have made Y connection, and what design we have made in the SSP, the existing SSP, we have provided a circuit breaker and taken two interrupters. One interrupter will feed from station yard to the exchange yard, then from exchange yard to the siding line, up to siding. The length of the siding was so big, it has one exchange yard, then another portion inside the plant. So we have decided to make it with two interrupters, because failure of one portion, the full section should not suffer. And with this use of interrupter and SCADA, the interruption will be minimum. So according to the length of the siding, you have to decide further you will feed with remotely, then you need number of interrupters and feeder line. Otherwise you can form an SSP in the mid section of the siding. According to the situation you have to decide. For example, I will show you the Band SSP later. It is a big portion, big chapter. Step by step I will discuss it, how to design. Now I will draw the siding line slowly. So first you have to take the wind pressure in that area. According to the wind pressure, we have to decide the span of the OHE mast. Okay. Next, the power supply from the circuit breaker has been shown here, but it will be the last end. Means you have to prepare everything, but when OHE section will be completed, then you have to simply jumper it. You know how to connect. You have to make a mast gantry near the OHE conductor and with feeder wire and with an single pole isolator you connect it with the OHE, because during for feeder line maintenance, simply you switch off the circuit breaker and the single pole isolator of the feeder line, and make the maintenance, or during any failure or breakdown of the feeder wire you can attend it, but at that time your turnout single pole isolator will be closed. Your turnout single pole isolator will be in closed position. Okay. Next, I'll show you a section of LOP so that you can understand, because without LOP it is difficult. It is not possible in PowerPoint to draw the everything and make it video. So I'll take it from the existing LOP. Okay. You have to estimate the number of structure, not estimate in the design you will put, then you have to count it, what type of mast you have used, and according to the OHE load you have to choose your mast. B150 simple single cantilever, and mainly single cantilever we are using B150. Okay, for single phase 25 kV normal OHE, not for high rise OHE. For normal OHE where 5.60 the contact height, single phase 25 kV. For single cantilever we can use 150, but when your anchor attachment will come, maybe balance weight anchor, maybe balance anti-creep anchor. Better for balance weight anchor with cantilever you use B200, B175 is also used, but anchor mast you provide B175. And for triple cantilever, summer we need triple cantilever, there you use B250 better. Okay, so for the gantry mast and everything you can use S60, T150, TTU. Upright for TTC twin track cantilever, where sufficient implantation cannot be given for in between two masts, we are using TTC. It will be provided one side of the track and can catch the other second line OHE. It's upright. How much it has used? Then dwarf mast is used in anchor mast. Now initially we are not using dwarf mast in past days, but now we are using dwarf mast for anchoring a mast. Then we anchor it on the top of the mast, near it, not the full size mast. Its length has been given 4.35 and 3.85. Two types of anchor mast is there, and in your design what type you will use, you have to put it in a table, so that at a glance you can estimate your material. Okay. Next, you have to put the symbol in the drawing, that to be shown in a particular place, so that some who are reading this drawing, they can understand what is this. Okay, this is the symbols. It is called legend, and you have shown in your drawing all these things. So you have given it into a chart. Okay. Next, the conductors used, that also to be indicated in the drawing in a chart. So they have shown it. Here is overhead equipment, that means contact wire, catenary wire, tension length they have given, then anti-creep anchor, and the total also they have given. If feeder wire is there, then you have to show the feeder wire also. But in OHE feeder wire we are not, will not use here. We will use in the feeder wire in the feeding system from SSP. Okay. Okay friends, today up to this. Next I'll show you how to draw the LOP, layout plan. How will make the span and everything I'll show you. So today up to this. Next time we'll discuss all these things.